These are going to be some more interesting problems, and they're going to be mainly based on trigonometry and trigonometric functions. And so yeah, let's start with the derivatives. Now the first one is y is equal to 3 sine x minus 4 cosine of x. Now how do we do this? Yes, we use a simple formula. When we find dy by dx, we find 3, well, what is the derivative of sine x? We have cos x minus 4, what is the derivative of cos x? Minus sine x. So we finally have 3 cos x plus 4 sine x. Let's go to the next question. Alright, so this was the first one, and this is the second one. We have y is let me use another color. That's better actually. Let's use green. Yeah, green is better. We have y is equal to x cubed tan x. So we have dy by dx, and we can use which rule? Product rule. Alright, so the first function is x cubed. Let's find the derivative of the second function. We have sec square x plus, what is the derivative of the first function? 3x square times the second function, that's just tan x. So we have x cubed sec square x plus 3x squared tan x. And that's the second question done. Let's move on to the next question. Okay, so we have y is equal to cos x divided by 1 plus sine x. And how do you find dy by dx? Well, you can use quotient rule, which is a very nice rule. Dy by dx is equal to, what is the derivative of cos x? Minus sine x times the second function, that's 1 plus sine x, minus, what is the derivative of 1 plus sine x? That's cos x, because the derivative of a constant is 0, that's 1 is 0. So sine x, derivative of sine x is cos x times cos x. And then we have to divide it by the square of the denominator, that's 1 plus sine x whole square. And when we find that, minus sine x minus sine square x minus cos square x divided by 1 plus sine x whole square, which is, and you know this is has to be 1, this is simple, well, the trigonometric identity which we learned very early in the course. That's minus times 1 plus sine x divided by 1 plus sine x whole square, minus, that's 1 minus 1 divided by 1 plus sine x. I hope I haven't made any mistake. These 3 questions look properly done, and I hope you understand them. So we can take this, we can take this, we can take this. Let's move on to the next 2 questions. So yeah, let's just cut these. Let's just erase these now. Alright, so the next question is, y is equal to cosec of x, cosecant of x times cotangent of x. Now, this is pretty direct. Dy by dx, we can use the product rule again, and so cosec x times, this is the first function, times the derivative of cot x. What is that? It's cosecant square x, negative cosecant square x, plus cot x. And what is the derivative of cosecant x? That should be minus cot x minus, cosec x. And finally we have minus cosec cubed x minus cot square x cosec x. That's the final answer for this one, and we're done with this. And then the last one, in the last one we have y is equal to sine square x divided by cos square x. Well, what is that? That's just tan square x, right? So dy by dx essentially telling us to find the d by tan square x divided by dx. You can use a lot of rules over here, but let's use the chain rule now, right? So we have d of tan square x divided by d of tan x times d of tan x times divided by d of x. Now remember, I told you before that these should be the same. So tan square x is basically just writing tan x whole square, right? So these two things should be the same. And now we can use power rule over here. And after we use power rule over, we get 2 tan x times this part, which is sec square x, because that's the derivative of tan x. So the final answer should be 2 tan x sec square x. And notice that we got this part from here and we got the other part from here. Alright, so I guess we are done with the fifth question too. So we have done successfully all these questions. Now in the next video I'm going to be talking about logarithmic differentiation, which is pretty interesting because there's some new concepts and it is really easy to understand. So I'll try to explain it. Alright, so see you in the next video. Bye bye.